Friends! Calc project. The esteemed Eric Scotton is associate with Tulley. You can go now.
Oh, okay.
Alright, first problem. A ball is thrown vertically upward from a height of 6 feet with an initial velocity of 60 feet per second. Use A, parentheses, t equals negative 32 feet per second as acceleration due to gravity. Find the velocity function, nice. The position function, even nicer. The time for the ball to reach the maximum height, so nice. And the maximum height of the ball. Alright, so the position and velocity equations are right here, as you can see. This is d equals v0t plus half at squared. This is the position. And the velocity equation is v equals v0, the initial, plus acceleration times time. Let's keep moving. Solving for the time. So what you do here? You set it up equal to the height. So you get the y. You get the y's. So it's the height it's working with right here. So the height of the initial is 6, and then you multiply it by the y initial. It's hit at 60 feet per second. So 60 is there. You multiply that by the time. You don't know that. You're solving for that. You got to figure that out. You add that plus half negative 32, because that's the acceleration due to gravity, times t. You still don't know it. Squared. So the equation comes out 6 equals 60t minus 16t squared. You can't solve this one, you have to quadratic it. I know, it sucks.
I dig it.
He digs it. So, once you subtract, you get all your a, b's, and c's. Negative 16t squared plus 60t minus 6 is the equation now. A equals negative 16, because that's the one with the squared exponent, that's the biggest exponent. B equals 60, it has the lesser exponent, but still has a coefficient there. And C equals negative 6. Now, finding the time through the quadratic formula. Alright, what you got right here? Quadratic formula up top. Negative b plus or minus square root b squared minus 4ac over 2a. That's your formula right there. Once you plug it all in, negative 60 plus or minus root 60 squared minus 4 times negative 16 times negative 6 over 2 times negative 16. So once you do all that math, you jumble all that math around, yeah, you get t equals 3.65, but that's the time over the whole slope. So you got to cut that in half to get the maximum height, and the time for the maximum height is 1.82 seconds.
Do that song for the radical.
Alright, now you got to plug in the time into the position equation to find the height, and subsequently found the max height, and that's what I did.
You want to do it?
Just did it.
You have to take the height equation again, but this time you don't know the height. You got to solve for the height. So you get the initial velocity, 60, times 1.82, the time you solve for, plus half of the acceleration due to gravity, negative 32, times the time, 1.82, squared. So what you get after all that math, what you get is 109.2 minus 52.99. And the answer for the max height is 56.21 feet is the max height.
Hey, hey!
Let's get a clap on that one.
Woo!
There you go.
Yeah!
Alright, next one.
Alright.
Alright, number 2, guys. I'm
No!
not even done yet.
This is a long process.
No, dude, this is just my half, too.
No.
The volume V, in liters, of air in the lungs during a 5-second respiratory cycle is approximated by the model V equals 0.1729 T plus 0.1522 T squared minus 0.0374 T cubed, where T is the time in seconds. Approximate the average volume of air in the lungs during one cycle. First of all, I know you're going to hate this one, but you got to antiderive it, so it sucks.
Yay.
So what you do, you antiderive that, you add on an exponent and then divide by that exponent's number. So you get 0.1729 t squared over 2 plus 0.1522 t cubed over 3 minus 0.0374 t to the 4th over 4. Alright, plug in 0 and 5 for t because they are the intervals in this equation. And the 5 and the 0 and the anti-derived thingy, the squiggle. That's what it is.
Integral.
The squiggle.
Integral.
Integral. Integral.
We'll keep it as squiggle. That's scientific.
Squiggles.
So f of 5, you got to solve for that. You just plug it in for all the t's, and after that you get 2.16. That's for the first one, plus 6.34 for the second one, and minus 5.84. So after all that's done, you get 2.66 for the answer to f of 5 plugged in. F of 0, obviously, is going to be 0. If I got that wrong, please give me a 0 on this project. I'm serious.
Oh, D.
So you take, now you minus the top from the bottom. So you minus 2.66 minus 0. That's 2.66. If I got that one wrong, you can give me a 0 too.
Oh, D.
Now you divide 2.66 by 5 because that's the interval on the equation is the biggest one. You divide that, you get 0.532 liters cubed for the volume.
Question 3. The force F in newtons of a hydraulic cylinder in a press is proportional to the square secant x, where x is the distance in meters that the cylinder is extended in its cycle. The domain of F is 0, pi over 3, and F of 0 equals 500.
It's silly.
Alright, so part A. Find F as a function of x.
Holy.
So up here, we have the integral of secant squared x as 0 goes to pi over 3. And it's secant squared x because it actually find that in the problem. So, so you take the integral of that, which is tan of x, and you add c. And so, as f of 0 equals 500, so you plug in 0 for x, and set it equal to 500, so you have tan of 0 plus c equals 500. And tan of 0 equals 0, so c will equal 500. So your equation is, or the function is tan of x plus 500. Alright, so now part B. Find the average force exerted by the press over the interval 0, pi over 3. So you have your function, tan of x plus 500. So you plug in pi over 3, so tan of pi over 3 plus 500 equals 501.73. And then you plug in 0, and you get tan of 0 plus 500 equals 500. So you take the 501.73 minus the 500, and that'll give you the average, which is 1.73 newtons. Yeah. Right. So question 4. At the instant the traffic light turns green, a car that has been waiting at an intersection starts with a constant acceleration of 6 feet per second. At the same time, or the same instant, a truck traveling with a constant velocity of 30 feet per second passes the car. Alright, so part A. How far beyond its starting point will the car pass the truck? Right, so the car. You know that its acceleration is 6 feet per second. So what you do is you start with the acceleration, you anti-derive that, and you get 6x plus c is the velocity. You solve for c, and you plug in 0 for x because the velocity, so you plug in 0 for x, and c equals 0, so it doesn't really matter. And then so the velocity is 6x. Then you anti-derive it again to get the distance formula, and it's 3x squared, and c doesn't matter there because the truck and the car both started at the same point, so there's no difference. Alright, so you know the velocity of the truck is 30 feet per second, so you anti-derive that, and you get the distance function, or the distance equation for the truck is 30x. So you set the two distances equal to each other, because what you're trying to find out is how far will they pass each other. So you have 3x squared equals 30x. You divide both sides by x, then so you get 3x equals 30. Divide both sides by 3, and you get x equals 10 seconds. So 10 seconds down the road, the car will pass the truck. Now what you do is you plug the 10 seconds in for the distance equation for the car to find how far it will travel before it passes the truck, and you get 300 feet down the road. Next. Alright, part B. Now, how fast will the car be traveling when it passes the truck? So, you already have the time. So all you do is you take the velocity function for the car, so which is 6x, and you plug in the 10 for x. So you get 60 feet per second.
Impressive, my friend.
Oh, we're done.